Hi class, in Chapter 2 the major focus will be prime factorization and the fundamental theorem of arithmetic. We have 4 lessons in Chapter 2. We're going to start off with lesson 2.1 and look at prime factorization and factor trees. We will then investigate multiples and least common multiples, move on to investigating factors and greatest common factors, and finally wrap up Chapter 2 with using GCF and LCM to solve problems. Learning targets for lesson 2.1, we will be determining the prime factorization of a number, understanding the usefulness of prime factors, and recognizing that each whole number has exactly one prime factorization. A lot of key terms in lesson 2.1. One I want you to make sure that you look for is the associative property of multiplication. We are going to compare that to the commutative property of multiplication that we talked about in Chapter 1. In problem number 1 on page 52, we will be looking at the dimensions of a tank. We determined dimensions for display cases using factor pairs back in Chapter 1. Let's consider other ways to represent the factors of a number. The think tank designs and creates customized tanks and aquariums for oceanographers. A team of oceanographers who study the characteristics of plankton requested a tank that has a volume of 240 cubic feet, but they didn't give the dimensions of the tank. You have been asked to help the think tank list possible tank dimensions using the information about the tank's volume. Recall that volume is the amount of space occupied by an object. The only rule you need to follow is that none of the dimensions can be 1 foot. To calculate the volume of a tank, multiply the tank's length by its width and by its height. You can see we have the formula right here in order to find the volume of the tank, length times width times height. To get started with your group today, I would like you to do number 1, complete the table by listing 3 possible tank dimensions for the volume given. Remember, the only rule that you need to follow is that none of the dimensions can be 1 foot. So go ahead and do number 1 with your group members. Here are 3 examples that you could have for the possible tank dimensions. In each of the examples, when we multiply the length by the width by the height, we get 240. So as long as your measurements gave you a volume of 240, you were good to go. In one, we have 4 by 6 by 10, 12 by 5 by 4, and 15 by 2 by 8. If we move to page 53, go ahead and answer number 2 with your group members. How did you determine the possible dimensions of the tank, and how did you verify that you were correct? The first thing that you would have had to do for any of your answers was determine a factor pair of 240. In this case, the answer key is giving us 4 times 60, and then you are going to determine another factor pair of 60, which would be 6 times 10. So 4 by 6 by 10 is going to give you 240 for your tank dimension answer. You can check your answer by multiplying all 3 factors together in order to make sure that your product is 240. Before you answer number 4 with your group members, let's take a look at the word bubble and the crew member helping us out here. It says that you can write any whole number except for 1 as a product of prime numbers. So 4 as a product of prime numbers would be 2 by 2. So keeping that in mind, for number 4, I want you to write the volume as the product of prime numbers for each row in your table. And after you write those down, take a look at each of the rows, and hopefully you notice something that is the same with all 3 rows. Go ahead and do number 4 with your group. Whatever the tank dimensions were that you ended up writing down back on page 52 for number 1, you are going to end up with the same factors, but they might just be in different order. So you can see for the first example, for the 4 by 6 by 10, I have 2 times 2 times 2 times 3 times 2 times 5. For the second example, which was 12 by 5 by 4, I have 3 times 2 times 2 times 5 times 2 times 2. And finally, for the third example, for 15 by 2 by 8, I have 3 times 5 times 2 times 2 times 2 times 2. In every single example, you are still getting 240 for your product. A natural number written as the product of primes is the prime factorization of that number. Prime factorization is the long string of factors that is made up of all prime numbers. Take a look at number 5. It says, does the order of factors make a difference, and explain your reasoning. So go ahead and answer number 5 with your group members. For number 5, the order does not make a difference because when you multiply all the factors together, you are still going to get the original number. Down at the bottom of page 53, we see that it says, recall that the commutative property of multiplication states that changing the order of 2 or more factors in a multiplication statement does not change the product. So hopefully we remember that from chapter 1. For instance, if we look at the example shown below, 3 times 5 is going to be equal to 5 times 3. If we turn to page 54, up at the top it says the associative property of multiplication states that changing the grouping of the factors in a multiplication statement does not change the product. So now we're focusing on this grouping word. For any numbers a, b, and c, the quantity of a times b times c is equal to a times the quantity of b times c. Let's take a look at the example they give us of implementing the associative property of multiplication. You can see that we have the quantity of 2 times 3 is equal to the quantity of 2 times the quantity of 3 times 3. So all they did, the order of the factors is the same, but all they did was change the grouping. They moved the parentheses. So you can see that if we follow the order of operations, 6 times 3 is going to be equal to 2 times 9. Your product is going to be 18. Take a look at number 6 and go ahead and answer it with your group members. We want to try to understand what the difference is between the commutative property of multiplication and the associative property of multiplication. The difference between the two properties is that the commutative property of multiplication states that changing the order of the factors does not change the product, while the associative property of multiplication states that changing the grouping of the factors does not change the product. Let's take a look at number 7 and get some practice with understanding the associative property of multiplication. It tells us to rewrite each set of factors using the associative property of multiplication. Remember, you are changing the grouping of the factors and you are not changing the product. So go ahead and do letter A, B, and C for number 7 with your group members. If we take a look at letter A, we should now have 3 times the quantity of 4 times 5. For letter B, the quantity of 6 times 5 times 3. And for letter C, 2 times the quantity of 3 times 5. If we take a look at number 8, now we want to determine the product for each set of factors in question 7. Which set of factors did you use? The set that was given or the set that you rewrote using the associative property, and explain your choice. So go ahead and do number 8 with your group members. If we take a look at number 8, and again referring back to question 7, for letter A, your product is going to be 60. You are probably going to use the factors that you rewrote. It's easier to multiply 4 times 5 first, getting 20, and then multiplying by 3 to get 60. For letter B, you're probably doing the same thing. Your product is 90. You're going to use the set of factors that you rewrote. 30 times 3, probably a little easier to get 90 than multiplying 6 times 15 in your head. For letter C, you probably just went with the 6 times 5, the set of factors that were given. 15 times 2, really not that difficult, but maybe 6 times 5, a little easier to come up with your product of 30. Let's turn to the top of page 55 and finish up with Problem 1, if we take a look at number 9, it says write the prime factorization of 240 and list the factors in order from least to greatest. So go ahead and do that with your group members. The factors listed in order from least to greatest should be 2 times 2 times 2 times 2 times 3 times 5 to get your product of 240. Let's move on to problem 2 on page 55 and talk about factor trees. A factor tree is a way to organize and help you determine the prime factorization of a number. Factor trees use branches to show how a number is broken down into prime numbers. Just a quick reminder from our crew member here, this is actually the teacher, that you can use either the X or the dot as symbols to represent multiplication. Make sure that you use one symbol throughout each multiplication sentence when you are putting your factor trees together. At the bottom of page 55, just an example of a factor tree, and we're going to look at again the number 240. So the first thing we're going to do is start by writing the number 240 up at the top, and then we are going to choose any factor pair, but we are not going to use 1 as a factor. We are going to draw a branch from 240 to each of those factors then. This is why you did not choose 1 in the think tank problem when we started off the lesson. So in this case we choose 8 times 30 as a factor pair for 240. If we look at the box on the left, if one of the factors is a prime number, we are going to circle it, and that is going to indicate that that branch is complete. If one of the factors is a composite number, then we are going to continue to choose factor pairs until all of the factors are prime numbers. And again, we are not choosing 1. So in this case, they choose 8 and 30. Neither of those are prime numbers, so we want to break both of those numbers down. 2 and 4 for 8, 2 is prime, so we circle it. 3 and 10 for 30, 3 is prime, so we circle it. 4 is broken down into 2 times 2. And 10 is broken down into 2 times 5. So we have then our prime factorization of 240, 2 times 2 times 2 times 2 times 3 times 5. Let's take a look at the top of page 56. Number 1 says to complete each factor tree, then write the prime factorization as a mathematical statement. What I would like you to do is letters A, C, and E for number 1. You are only doing those 3 letters. You are figuring out the prime factorization for 240, 720, and 360, just A, C, and E. Go ahead and do that with your group members. If we take a look at letter A, the prime factorization for 240, 2 times 2 times 2 times 2 times 3 times 5. For letter C, 720, it would be 2 times 2 times 2 times 2 times 3 times 3 times 5. And for letter E, 360, 2 times 2 times 2 times 3 times 3 times 5. Let's look at the top of page 57. Did you notice that 2 and 3 were repeated factors of the prime factorizations in the factor trees you created? The prime factorizations were long, and you had to write a lot of numbers. Because 2 and 3 are repeated factors, you can write their repeated multiplication using a shorthand method. This method is called a power. A power has 2 elements, the base and the exponent as shown. The base of a power is the factor that is multiplied repeatedly in the power, and the exponent of the power is the number of times the base is used as a factor of repeated multiplication. So if we look at our base number 2, our exponent is 4. The exponent is telling us to multiply the number 2 by itself 4 times. You can read a power in the following ways. 2 to the 4th power, this would be the one that I prefer. 2 raised to the 4th power, or the 4th power of 2. Again, the top one would be my preference, but you can choose to read it in any way that you would like. Number 2 tells us to identify the base and the exponent in each power, then write each power in words. So do A and B with your group members. For letter A, the base is going to be 7 and the exponent is going to be 2. You could say 7 raised to the second power. You could also say 7 squared. 2 is a special exponent that we can use the word squared for. For letter B, the base is going to be 4, the exponent is going to be 3. You could say 4 raised to the third power. You could also say 4 cubed. 3, much like the number 2, is also going to have a special name when we use it as an exponent. So squared for 2 and cubed for 3. Remember that when you are using 2 and 3 as exponents. If we take a look at number 3, we're going to write the prime factorizations using powers now for the factor trees that we completed in question 1. Remember, we only did letters A, C, and E, so go ahead and do that with your group members. If we look at letter A, we should have 2 to the 4th power times 3 times 5. Remember, we want to try to write these prime factorizations in numerical order. Letter C, 2 to the 4th power times 3 squared times 5. And for letter E, 2 cubed times 3 squared times 5. If we turn to the top of page 58, we can see that the fundamental theorem of arithmetic states that every natural number is either prime or can be written as a unique product of primes. If we take a look at number 4, we are going to determine the prime factorization of each number using factor trees, but this time now we are going to write the prime factorization using powers. So go ahead and do letter A, B, and C with your group members. If we take a look at letter A, the prime factorization for 180 should be 2 squared times 3 squared times 5, and for letter B, we should have 3 to the 4th power. That is the prime factorization for 81. For letter C, for the number 48, we should have 2 to the 4th power times 3. Let's turn to page 59. We are going to skip number 5 and 6 and finish up lesson 2.1 with number 7. What we want to do is use exponents to make each prime factorization true. So I want you to finish up and do letters A through D with your group members. For letter A, 24 is going to be equal to 2 cubed times 3. For letter B, 45 is going to be equal to 3 squared times 5. For letter C, 54 is going to be equal to 2 times 3 cubed. And for letter D, 72 is going to be equal to 2 cubed times 3 squared. That is going to do it for lesson 2.1 on prime factorization and factor trees. Please let me know if you have any questions. Thanks.